Thank you. Our third speaker is RJ Waken, an instructor in the Division of Biostatistics and an analytic lead at the Center for Advancing Health Services, Policy, and Economics Research at Washington University School of Medicine in St. Louis. Your slides are here.
I appreciate you reading off that long line of words because I never seem to get the order right for Casper. We call it Casper because that's a nice, cute name. All right, how do I just click this, right? Yeah. Just want to make sure this actually moves along. Oh, I can even see the next slide. This is amazing. It's way better than the classroom I have to teach in. All right, so I did change the title for this slightly because this is a little bit more catchy, and I get a cute little acronym out of it with BUSTS. I'm going to call this Bayesian Updated Structural Time Series, and I'm sorry to the organizers I didn't update the title with you all before just kind of dropping the slides on you. This is a small project right now. It's still in its infancy, really. I'm the guy up there at the top left. Karen, you all heard from yesterday. She's the PI that helped get us all involved in the work for this grant. And then I always like to shout out Feng Shen. Feng Shen is our analyst. Without her, we'd be looking at blank white pages. She does like all of the hard stuff so we can do all of the fun stuff. So let's talk about this project in the data set that we used. This is more of a methods-focused project. So we implement a lot of things in the context of causal inference. Interrupted time series or structural time series models are usually how I like to approach those. And there is a lot in the literature concerning how you can evaluate those effects when you might have different intervention effects across different groupings of units. Some of those are different units over time. Some of them are different units at a single time point. We're going to focus on that part of it. So how can we characterize a single disruption or intervention effect and allow it to vary across different units? The second part of this project came about because many of us, how many VRDC users do we have? We have a few in here right now. So many of us were using the VRDC, and a few months ago, it just kind of stopped working. It would kind of work, it would kind of chug along, but you had to really work to make things like to fit your data into a small enough bucket for it to actually run, or it would just blow up on you. It's very frustrating. I spent the first month of that 2-month period swearing at my computer. The second month, I decided to do something about it and try something new. So how can we implement a really complex model like this in a system with resource constraints? How can we be a little bit more flexible with how we implement things is more or less what this is. How can we work with the reality of the systems that we have instead of like a supercomputer that we would all like to use? Now, the application for this particular talk is just going to be a disruption in doctor's office visits during the height of the COVID pandemic. I'm hand waving some of those words. The height of the COVID pandemic part that we're looking at is actually the height of the disruption in what we saw in doctor's office visits in our cohort in Medicare. Now, speaking of Medicare, that's actually the data that we're going to be looking at. So weekly throughout 2018 and all the way through 2020, we built a cohort of fee-for-service Medicare beneficiaries with one of the following conditions coded in any visit in the prior 2 years. So some of you all are probably familiar that Medicare has a chronic conditions file that has all of these in it. This is the same thing you would find for those files, except we remade this on a week-by-week basis so that people could come in or fall out of that cohort if they didn't have a visit like more or less exactly in that 2-year period. Now, I said doctor's office visits. These were really evaluation and management visits. That's what the technical term is. We took all comers there as long as they didn't happen in an inpatient setting. So if somebody's rounding in the hospital, they perform an evaluation and management visit, we're not counting that in this group. We did allow telehealth in here as well. We have not separated that out, but that is something of interest in the future in this project. So methods. I'm going to keep this very high level. I don't have any equations, no Greek letters, nothing like that. And I'm sorry for the statisticians in the room. but we only have 10 minutes. So what we're doing is we're going to try to put together a structural time series model with county observations across 168 weeks, I believe. That's a lot of data. That's very difficult for a computer to do. We're actually fitting a model that accounts for spatial correlation as well. So it's a fairly complex model. We don't actually have all the counties in the US represented. The reason that we're missing some is there were actually no fee-for-service beneficiaries in that cohort that I just described in some of those counties. That's why it's 3,135 instead of 3,153, I think. So what we're going to do to overcome those resource constraints that were dropped on us is we're going to fit this model weekly. Then we're going to share information time forward using informative hierarchical power priors. This includes what typical time point to time point variation, or if you're more familiar with some of the terms in time series, like an innovation term would look like. Then we're going to borrow from the clinical trial literature, and we're going to use commensurate power priors to help evaluate similarity of current and historical parameters. Now, why are we doing this? Well, if you look at the prior, this puts on the piece that looks like an interruption term. It actually looks just like what you see in a more traditional Bayesian structural time series model. It actually has that variable selection look to it. Now, this part of this is going to help us answer the question, how do we know if the time to time jump is typical or atypical? Is it some kind of disruption that we're seeing, or is this just typical variation? In the econometrics literature, like I said, there's a lot of concern about how to characterize some of these causal effects if they might differ by units. Remember, we're looking at this at just a single time point for this study. There have been a few papers that have looked at this over space specifically. So we're going to allow for county level interruption or disruption effects by utilizing a special prior that basically launches off that other prior that we specified on the overall interruption effect. And it allows us to vary county by county. So we can have a different interruption effect in each county. Now, what you can do with this is you can either aggregate information from a bunch of counties and characterize what's happening in like rural health or by social vulnerability index. Those are the two examples we're going to look at. So let's talk about results, but I have more words first. We're going to focus on the first 5.5 or so months of 2020. This is where we see the biggest set of changes in this particular outcome. That's why we're focusing in on this. And it helps me like really point out what's happening in some plots. So first I'm going to show you overall what happened. And then I'm going to show you what happened stratified by rurality defined by core-based statistical area. You get 3 buckets there: metropolitan, micropolitan, and then technically none, or what we call rural. And then we just use social vulnerability index to get an idea of county level vulnerability. Then I'm going to show you all plots of the county level disruption effects for the 12 weeks listed in that time period. All of these inferences concern the rate of E&M visits per 7 beneficiary days. So if we look at the thing on the bottom, I don't know if I have a pointer. No, I'm not going to hit the, oh yeah, I do. No, I don't. Okay, never mind. I just can't see it. If I can't see it, it's probably not too useful. So this is the overall effect right here. I think you can't see my mouse. Look at the bottom one. The bottom is overall. This is like the typical disruption effect. So we're going along. We start in January 2020. Nothing's happening. Nothing's happening. We hit early March. Nothing's really happening. And then in mid-March, it just starts to tank. Hits the trough in early April, and then slowly kind of climbs back up until we hit June. Now, if we look at it by rurality, which is the top plot, we actually see just kind of a mix. It's like just all kind of mashed together. The interesting one in this group of plots, I think, is the social vulnerability index. We characterize social vulnerability index at the county level. Lighter colors indicate higher vulnerability. Darker colors are less vulnerable. And what you actually see is that the more vulnerable counties actually had less of a drop. We can also look at this at the county level, and you can see some spatial patterns and where these disruptions seem to be occurring. So I plotted all of the 12 weeks that I referenced. That first one that gets really dark is where you really start to see those interruption effects. And then if you look at like 3:30 and you look at this kind of this area, the upper Midwest, we actually see a really dark spot there compared to the rest. And then as we're coming back out, we actually see that different counties kind of come back at different rates too. So future direction, and I also included references. So methodology wise, one of the next step for me is to share disruption information time forward. That's actually evaluated independently at each time point. That allows us to see what's happening at every time point and detect whether there's a change really easily, but it's a little bit inefficient in terms of information sharing. And then application, literally just every other application, specifically actually interested in telehealth. Thank you to the consortium for the opportunity to present this. This was really fun. This has been a great conference.